Okay, so we take measurements in order to quantify an observation. We observe how long something is, we observe how much something weighs, and we have to get a number to quantify that, called a measurement. Okay, when we read an instrument, like a meter stick, we're going to read what the instrument gives us, and we estimate one more digit. This is really important. Okay, next class we're going to do a measurement activity, and then we're going to practice taking measurements and then converting measurements. So we need to understand what that means. We read what it gives us, and we estimate one more digit. So for example, on this meter stick, centimeter whole numbers are marked, and then there's millimeter ticks on there, right? So it's broken down to the millimeter. So if I was going to measure something in centimeters, and I found that it was 48.2 centimeters, right? It's in between that 2 and that 3 millimeter mark. I'm going to estimate where it is between the 2 and the 3. Okay, so I might say it's 48.24 centimeters, if it falls somewhere in between that 2 and that 3. So you read what it gives you, wherever that is, and you estimate one more digit. If your device were only going to measure to whole numbers, okay, like some graduated cylinders only measure to whole numbers, that means I would need one decimal place to go with that, right? It's somewhere between 38 and 39, so I'm going to find where I think it is in between there and estimate that last digit. Okay, does that make sense? Read what you're given, estimate one more. Once we have our measurements, we can evaluate how accurate and how precise they are. Do those words sound familiar to you? Accuracy and precision, do they sound familiar? Yeah. Can anyone tell me the difference between accuracy and precision?
Accuracy is
Okay. Okay, great. Thanks. Precision is how close together your measurements are. Okay, how close together your measurements are. So if you take a lot of measurements, you take 10 measurements, and they're all really close to one another, we would consider them precise measurements. Okay. Does that mean that they're all necessarily correct? No, right? You could be wrong, but you could be wrong 10 times. So if we have a group of numbers with very little variance, right? The numbers don't vary very much. We consider those a precise group of measurements. Okay. Accuracy, on the other hand, is how close to the actual value they are. Accuracy is close to actual. Okay. How well they agree with the real or accepted or actual value. Okay. So accuracy is like the actual. Sorry. Other. How can a measurement be precise but not accurate?
If it's inconsistently together, I don't know if I worded that right.
Okay, so just like the purple example that we showed, we are hitting one spot on the target, but it's not where we want to be hitting, right? So we're doing the same thing incorrectly over and over and over again. That's like if you were to read a meter stick, and it should be between, it should be 42 and a half, but you keep reading it at 43 and a half, right? If you just are misreading it, but you do it over and over and over and over again, it's going to give you a precise measurement, but not an accurate measurement. That makes sense? So incorrect reading of an instrument could be an example of a precision error. Okay? We have precise measurements, but they're not accurate. Okay, if you have different people reading an instrument throughout an experiment, so if I read the first measurement, and then Amelia reads the second measurement, and then Sammy reads the next measurement, and then Kat reads the next measurement, we could have measurements all over the place, right? One of us might be reading accurately, one of us might not. The other one might be reading accurately, the other one might not. Okay, so we could have a problem there. We won't have precision, but we could have accuracy. So it's important that one person throughout a set of trials reads the same instrument so you can get some sort of consistency throughout that trial. Okay, so here's an example. You don't have to write this down. I want you to read through this scenario and tell me who has the most accurate and the most precise. Okay, so read through the example at the top and then pick out for me who's the most accurate and who's the most precise. pick in your head A, B, C, or D, and then just hang on and I'll take a little poll here. Let's talk about identifying an independent and a dependent variable. Please tell me you know what those things are.
Yes.
Okay? Lie to me. I'm just kidding. At least you've heard independent variable and dependent variable some point in your scientific careers, right? Okay, so a variable is any factor that might affect the behavior of an experiment. Anything that we're changing, anything that is being changed in a scientific experiment is considered a variable. Okay, so the independent variable, it's the factor that is changed or manipulated during the experiment. It's what we control. Okay, the independent variable is what we control. It's what's being changed. So we control the independent variable. The dependent variable then is the factor that depends on the independent variable. Okay, it's the one that's being measured. So that might be a better description for you there. The dependent variable is the one being measured. Okay. So if we're doing an experiment to measure something, we want to put the dependent variable. I'll show you here on the graph where it goes. Can anyone tell me on a graph like this right here which is the dependent variable and which is the independent variable? Which goes on which axes? Do we know? Good. Dependent. No, the other way around. Dependent goes there. Independent goes there. Okay, that's okay. Independent goes on the bottom because we can put it at regular intervals, right? We're measuring something at regular intervals. Okay, and then the dependent variable can change as it goes along. Okay, does that make sense? So dependent variable goes on the y-axis, independent variable goes on the x-axis. Okay, if we're given a table of data, right? Sometimes it says graph this data. This is usually the independent variable, so it goes on the x-axis. This is usually the dependent variable, so it goes on the y-axis. Okay, so in your experience or in your like homework today, when you're graphing some data, this would be a good idea to follow. Okay, most of the time your independent variable is going to be listed first, and those are going to be the ones that are at regular intervals because you are able to control it. Okay, the dependent variable is at less regular intervals. Okay, does that make sense? Questions there? Okay. All right, in a linear relationship, we have what we call a line of best fit. Okay, and that line of best fit is a straight line. The dependent variable varies linearly with the independent variable. So they have a direct relationship. Okay? We'll see a perfectly straight line at where those two things are meeting. This equation over here, does it look familiar? Okay, or if I write it like this. That one looks more familiar? Okay, and what is that used to find? The slope of a line. Okay, so the only thing that's different between these two equations is this little delta symbol. Do we know what delta means? It means change in, okay, or it means final minus initial. You'll see a delta used a lot in your physics equations. Okay, and all it means is final minus initial. 2 minus 1. Okay? So these two things mean the same thing, but you need to be able to kind of identify it with that delta symbol. Okay? So delta means change in or final minus initial. Okay? This is the equation that you'd use to find basically the equation of that line, right? Y equals mx plus b is the equation for a linear graph. Hopefully we recognize that equation. So for relationships that are nonlinear, we're going to look at a couple different types here. First, we're going to look at a quadratic graph. Okay, this is when one variable depends on the square of another, and we'll see one of these on our homework today. Okay, there's our equation for a quadratic graph, and I'll show you what it looks like here. Here's a quadratic graph up at the top. Okay, so we see a curve up like this. Okay, these two types of graph are much less common. You need to really focus your energy on a linear graph, okay, and how to graph that and what it would look like. But I'm going to show you what these two look like in case we need it. Okay. So quadratic, and here's our variable equation, and then an inverse graph starts high and avoids the origin. Okay. Inverse is when one variable depends on the inverse of another, so 1 over something.